Tonight, we are going to explore one of the largest questions a curious mind can ever ask. How many galaxies does the universe really contain? Here's the strange part, and I'm going to give it to you right at the start, because it is far too good to make you wait for. Point our finest telescope at a scrap of sky that looks completely empty, a speck of pure black nothing, and that nothing quietly fills with thousands of galaxies. And when astronomers try to add them all up, they do not agree. Our best answer today is not a single number. It is a range, and an enormous one. Somewhere between 200 billion galaxies and 2 trillion, depending on which method turns out to be right. The universe may hold 10 times more galaxies than we can currently see, and every one of them carries hundreds of billions of stars of its own. We have measured the width of the visible cosmos and peered back almost to its beginning, and yet we still cannot pin down this one number to within a factor of 10. That gap, that quiet argument between two careful answers, is the heart of tonight's story. You will hear how a patch of empty darkness turned out to be secretly crowded, how two clever measurements arrived at numbers 10 times apart, and why most of the galaxies in the sky will one day slip beyond our reach forever. If you find the quiet corners of the universe as soothing as we do, take a soft moment to like this video or subscribe. It is a small thing, but it helps these gentle journeys reach more curious minds like yours. And now, settle in. There is nothing to remember tonight, nothing you need to follow closely, nothing to hold on to at all. Let the words keep you company, and let your thoughts grow slow and calm. Let us begin. Step outside on a clear, dark night, far from the lights of any city, and look up. If your eyes are good and the sky is truly dark, you might see a few thousand stars. That is all. A few thousand points of light scattered across the dome of the sky. And here is something most people never realize. Every one of those stars belongs to a single galaxy, our own, the Milky Way. Every star you have ever seen, every constellation you have traced, every shooting star, every planet, all of it lives inside this one structure. That faint band of pale light arcing across a truly dark sky, the soft river that gave the Milky Way its name, is not a cloud. It is the blended glow of hundreds of billions of stars, too far away to see one by one, packed into the flattened disk of our galaxy as we look toward its crowded center. For thousands of years, that band of light was simply a mystery. People saw a river, a road, a trail of spilled milk poured across the heavens. Nobody knew what it truly was. And yet, with the naked eye alone, from a dark enough place, you can already see another galaxy. You simply do not realize it. If you know exactly where to look on the very best nights, you can find a small, faint, fuzzy smudge in the constellation of Andromeda. It looks like almost nothing, a little gray blur, a flaw in the darkness. That blur is an entire galaxy of roughly 1 trillion stars, and the light reaching your eye from it has been traveling for about 2.5 million years. When that light first set out, there were no modern humans on Earth. You are looking at the most distant thing a human eye can see without help, and to your eyes it is nothing more than a faint stain. From the southern half of the world, there are two soft glowing patches that look like torn pieces of the Milky Way drifting beside it. These are the Magellanic Clouds, 2 small galaxies that circle our own. And sailors used them to steer by for centuries without ever suspecting what they truly were. So you can understand why, for almost all of human history, we believed the Milky Way was everything. It was not arrogance. It was simply what the evidence showed. The Milky Way seemed to hold every star, and beyond its glow there appeared to be only darkness. That belief held firm until the telescope arrived and quietly began to take it apart. When Galileo first turned his small, crude telescope toward that band of milky light, it dissolved under his lens into countless separate stars, far too faint and too many to ever count by eye. The Milky Way, he realized, was made of stars. It was the first hint that the cosmos ran deeper than anyone imagined. And as better telescopes swept the sky over the next 2 centuries, astronomers kept noticing strange objects that were not sharp points like stars, but soft, cloudy patches. They called them nebulae, an old word for cloud. Some were truly clouds of gas inside our galaxy, but others had elegant spiral shapes, like whirlpools frozen in the dark, and nobody could say what they were. There is a small irony buried in their discovery. One of the first careful lists of these spirals was drawn up by a comet hunter who kept mistaking the fuzzy patches for the comets he was chasing, and who finally, in frustration, wrote down all the annoying smudges that were definitely not comets, so that he could ignore them. That list of cosmic nuisances, made so they could be dismissed, turned out to hold some of the most important objects in the entire sky. That single, unanswered question, what are the spiral nebulae, grew into one of the longest arguments in the history of science. One camp said they were small clouds of glowing gas, sitting inside our own Milky Way, mere features within the one galaxy that was the whole universe. The other camp held a bolder, almost frightening idea. They proposed that each spiral was a separate galaxy in its own right, a city of billions of stars lying impossibly far beyond our own. They gave these objects a beautiful name: island universes. If the bold camp was right, then our galaxy was not the universe at all. It was one island among countless others, scattered through an ocean of space so wide that whole galaxies shrank to faint smudges. And the whole question came down to one thing that nobody could measure: distance. If the spirals were near, they sat inside the Milky Way. If they were unthinkably far, they were galaxies of their own. Both sides argued passionately, and both were partly right and partly wrong, drawing reasonable conclusions from incomplete and sometimes misleading clues. But neither could win, because measuring the distance to a faint fuzzy spiral, perhaps millions of light years away, seemed completely beyond reach. Everything depended on a number nobody could get. The key that finally unlocked the door came from a woman whose name most people have never heard. Henrietta Swan Leavitt worked at the Harvard College Observatory in the early years of the 20th century. She was one of a group of women hired to do the slow, exacting work of measuring stars on photographic plates by hand. Women who were paid very little and were known, rather coldly, as computers, because computing was their task. They were rarely allowed to touch the great telescopes themselves. They were handed glass plates and endless columns of measurements, plate after plate, star after star, year after year. Leavitt was set to studying a particular kind of star that refuses to hold still. These stars brighten and dim in a steady, regular rhythm, swelling and shrinking over days or weeks. They are called Cepheid variables. As Leavitt measured hundreds of them with extraordinary patience, she noticed something no one else had seen. The rhythm of a Cepheid is tied directly to its true brightness. The slower a Cepheid pulses, the more luminous it genuinely is. It sounds modest, written down so plainly, but it was one of the most powerful discoveries in all of astronomy, because it turned these pulsing stars into cosmic measuring sticks. If you know how bright a star truly is, and you can see how bright it merely appears from Earth, you can work out exactly how far away it must be. A bright candle that looks dim must be far. A bright candle that looks brilliant must be close. Cepheids are candles whose true brightness you can read straight from their heartbeat, and yet Henrietta Leavitt did not live to see what her quiet discovery would do. She worked in poor health, for little pay, and almost no public credit, while others took her law and used it to remap the entire cosmos. She died before the world fully understood that the door to the universe had been opened by her careful hands, one faint star at a time. The man who carried her key through that door was Edwin Hubble, working with one of the largest telescopes in the world, high on a mountain in California. In the early 1920s, he was studying the Andromeda spiral, that same faint smudge you can see with the naked eye, and within it, on a long photographic exposure, he found one of Leavitt's pulsing stars, a single Cepheid, buried in the spiral. He watched it pulse across many nights. He measured its rhythm. He read off its true brightness using Leavitt's law, and then he calculated the distance. The answer was almost unbelievable. Andromeda was not inside the Milky Way. It was nowhere near it. It lay far beyond anything in our own galaxy, an entire separate galaxy of its own, exactly as the bold camp had dared to predict. Today, we know the true figure is about 2.5 million light-years, but even Hubble's first rough number was enough. In a single measurement, the universe exploded in size. Overnight, the Milky Way went from being everything to being one galaxy among many. And all those thousands of other fuzzy spirals that astronomers had catalogued, including the ones once dismissed as nuisances, were not little clouds of gas. They were other galaxies, each a Milky Way of its own, each filled with hundreds of billions of stars. And the obvious question rose up at once, the very question we are following tonight. If there are other galaxies out there, then how many hundreds, thousands, millions, or something far beyond what a human mind could hold? It is worth sitting with how quietly that revolution happened. There was no explosion, no single dramatic night the whole world remembers. There was a careful man on a cold mountain, measuring the same faint star over and over until he was certain, and a careful woman before him who had given him the rule that made the measurement mean anything at all. Between them, almost without anyone noticing at first, they took a universe that had been one galaxy wide and made it vast beyond counting. That is often how the deepest changes in our understanding arrive, not with a shout, but with someone patient enough to check a small thing carefully, and honest enough to follow where it leads. To even begin answering that, astronomers needed one more idea, and Hubble handed it to them, measuring how those distant galaxies moved. He found that almost all of them were rushing away from us, and the farther a galaxy was, the faster it fled. The universe was not standing still. It was expanding. The galaxies were not flying through space like debris from a blast. Instead, space itself was gently stretching, carrying the galaxies along with it, like raisins set in a loaf of bread that swells as it bakes, every raisin drifting away from every other. Run that expansion backward in time, and you arrive at the idea that everything began from an unimaginably hot, dense state, about 13.8 billion years ago. And this stretching of space gave astronomers a new tool, because the light from a distant galaxy is stretched along the way toward redder colors. And by measuring that stretch, they could estimate how far the galaxy lay, and how far back in time they were seeing it. With this, and with Leavitt's pulsing stars, and with a special kind of stellar explosion that always detonates at very nearly the same true brightness, and so serves as a brilliant beacon across billions of light-years. Astronomers built a ladder of distances, reaching rung by rung out toward the edge of the visible cosmos. But for decades, there was a wall they could not climb past. They could count the galaxies they could see, the bright, close ones. Beyond those lay an ocean of darkness, and nobody knew how full it was. The breakthrough came in the 1990s, with a telescope lifted entirely above the blurring atmosphere, the Hubble Space Telescope, named for the very man who proved other galaxies exist. And it came from one of the boldest decisions ever made in astronomy. The director of the telescope at that time was an astronomer named Robert Williams, and he chose to do something that, on the surface, sounded almost reckless. He decided to aim this priceless, endlessly demanded telescope at a patch of sky that looked completely empty. A small, dark, unremarkable speck near the handle of the Big Dipper, with no known bright stars and no known galaxies. Nothing at all. Pure black nothing. The patch was tiny. Hold a single grain of sand at arm's length against the night sky, and it would cover about the same sliver of space as his target. And the plan was to stare at that one dark grain for 10 straight days, gathering every faint particle of light that drifted in from that direction. Many people thought it was madness. He had spent his own special allowance of telescope time he could use however he wished, on apparent emptiness. What if there was nothing there? What if 10 days of one of humanity's most valuable instruments were poured into a photograph of pure black? It was a quiet bet, a reputation laid on the line, a wager that the darkness was hiding something. The telescope opened its eye on that little patch and held its gaze for days, catching ancient light one feeble photon at a time, and then the image came. That tiny scrap of supposedly empty sky was not empty at all. It was crowded. It was teeming. In that single grain of darkness, the telescope had captured around 3,000 galaxies. 3,000. Not stars, galaxies. 3,000 separate cities of stars in a patch of sky that most astronomers had assumed held nothing at all. Some were graceful spirals like our own. Some were glowing rounded ellipticals. Some were strange, distorted, half-formed shapes from the early universe. And many were so far away that their light had been traveling for billions of years before it finally landed on the detector. This is the part that turns a photograph into a time machine. When you look at a galaxy whose light has traveled for 10 billion years, you do not see it as it is now. You see it as it was 10 billion years ago, when that light first set out, long before the Earth or the Sun even existed. So the deep field was not simply a picture of distant galaxies. It was a picture of the past. The nearest galaxies showing recent times, the faintest, most distant smudges showing the universe in its infancy, all laid side by side in one small rectangle of sky. Billions of years of cosmic history caught in a single frame, and the logic that followed was impossible to escape. If a patch of sky that small, in a direction that looked completely empty, held 3,000 galaxies, then the entire sky must be carpeted with them. The darkness was not empty. The darkness was full. We had simply never looked deep enough to see it. The image became known as the Hubble Deep Field, and the gamble that everyone feared would waste 10 precious days became one of the most important photographs ever taken. It quietly settled the realization that had begun with Hubble decades before. The universe is not thinly scattered. It is densely, almost unbearably full of galaxies, in every direction, as far as we can see and at every age of cosmic time. To the astronomers who first saw it, the picture was almost overwhelming. They had aimed their instrument at what looked like a small piece of nothing, half expecting to have to defend the choice for years afterward. And instead, the darkness had answered them with 3,000 worlds of stars, each one a structure as grand as the galaxy we live in. It is one of those rare moments in science when a single image quietly rearranges how a whole species understands its place. The emptiness, it turned out, had never been empty. We had only been looking with eyes that could not yet see deeply enough. Astronomers did not stop there. If staring for 10 days revealed 3,000 galaxies, what would a longer, deeper stare reveal? A few years later, they pointed the telescope at another dark patch, this time in a southern constellation, and let it gather light across months of observation. This became the Hubble Ultra Deep Field, and in that single sliver of sky, smaller than a grain of sand held at arm's length, it captured around 10,000 galaxies. Many of them so distant and so ancient that they appeared as they had been when the universe was only a few 100 million years old, a tiny fraction of its present age. Later, astronomers stacked still more observations of that same region into an even deeper image, squeezing out the faintest galaxies yet, objects whose light had traveled for well over 13 billion years to reach us. There is also a quiet trick that nature itself hands us, letting us glimpse galaxies that should be far too faint and far too distant to see. Mass bends space, and light traveling through bent space follows a curved path. So when something enormously heavy, like a great cluster of galaxies, sits between us and something far behind it, the cluster's gravity bends and focuses the light of that distant object, working like a giant, natural lens floating in the dark. Astronomers call this gravitational lensing. By aiming their telescopes through a massive foreground cluster, they let its gravity magnify and brighten the faint galaxies hidden far beyond it. The distant light is often smeared into strange glowing arcs, warped by the lens, but it can be made hundreds of times brighter than it would be alone. In this way, the universe lends us its own great masses as lenses. And some of the most distant galaxies we have ever found were revealed not by our instruments alone, but by the gravity of everything in between. Now astronomers finally had a method to answer our question. Count every galaxy in one of these tiny, deep images. Measure how much of the sky that patch covers. Then multiply. The full sky is enormous next to one of these specks. To cover the whole sphere of the heavens with patches that small, you would need to tile the image millions of times over. So you take the galaxies in your patch and multiply by how many patches it would take to wrap the entire sky. And when astronomers did that arithmetic, they reached the first serious modern answer. The observable universe held somewhere between 100 billion and 200 billion galaxies, not stars, galaxies, and each one holding, on average, anywhere from a few billion to a few 100 billion stars of its own. For a long time, this was the number in the textbooks. Roughly 200 billion galaxies. It is a figure that already breaks the mind. If you tried to count 200 billion galaxies, naming one every single second, without ever stopping to sleep or eat, it would take you longer than the entire age of the universe to finish, and you would still not be close. And yet this enormous number turned out to be only the beginning, because a problem was hiding inside it. The deep field images could only show galaxies bright enough and close enough to register on the detectors. The faintest, smallest, most distant galaxies simply did not appear. Their light was too feeble, smeared across too much space and too much time to leave any mark at all. So 200 billion was never the true count. It was only the count of galaxies we could see, and those are not the same thing. In the year 2016, A team of astronomers, led by a researcher named Christopher Consolis, set out to fix this properly. They did not just count the galaxies in the pictures. They asked the deeper question: how many galaxies must be out there that we cannot see at all? To find out, they turned the deep field images into three-dimensional maps, sorting galaxies not only by position in the sky, but by distance, and therefore by time. Since looking farther away is the same as looking further into the past. And in the early universe, they found something striking. It was packed with small galaxies, far more of them crowded into the same volume of space than exists there today. That made sense, because over billions of years, galaxies collide and merge, small ones combining into larger ones, again and again. The young universe simply held many more separate galaxies than the universe around us now. By tracking how the count changed across cosmic time, and by modeling how galaxies form and grow, the team could estimate the entire population, including all the faint galaxies hidden below the reach of our telescopes, and the conclusion took everyone's breath away. At least 90% of all the galaxies in the observable universe, they found, are simply too faint and too far to be detected with present-day instruments. 90% of all galaxies, hidden in the dark, below the threshold of every eye we have ever built. When they added those invisible galaxies to the visible ones, the total leapt upward by a factor of 10. The new estimate was not 200 billion, it was around 2 trillion. 2,000 billion galaxies. A2 followed by 12 zeros. To even reach for that number, picture every galaxy as a single grain of sand. 2 trillion grains would fill heaps in containers you could not empty in 1,000 lifetimes. And each grain is not really a grain at all. Each one is an entire galaxy, hundreds of billions of stars, countless worlds, all crushed in our minds down to a single point of light. The figure of 2 trillion spread through documentaries and articles and textbooks, and the universe, it seemed, was 10 times more crowded than anyone had dared to imagine. There was one quiet subtlety folded inside it, though. That count gathered galaxies from across all of cosmic history into one tally. And since so many of those small early galaxies have long since merged together, the number that exists right now, in this present moment, is almost certainly smaller. 2 trillion was, in a sense, a count of every galaxy that has ever shone within our horizon, not a snapshot of how many shine there today. It is worth slowing down on a number like 2 trillion, because the mind slides off it so easily. We say it in a single breath, but we cannot truly picture it. 1,000,000 seconds is about 11.5 days. 1 billion seconds is nearly 32 years, most of a human life. And 1 trillion seconds is more than 30,000 years, reaching back beyond the end of the last ice age, beyond the first cave paintings, into the deep prehistory of our kind. Now take that already unimaginable span and double it. And then let every single one of those countless units stand not for a passing second, but for an entire galaxy of hundreds of billions of stars. That is the scale we are gesturing toward when we say the universe may hold 2 trillion galaxies. The words are small. The thing they point to is not. It was careful, beautiful work. And then, only a few years later, the ground shifted beneath it, because a completely different method gave a completely different answer. The new evidence came from one of the most distant spacecraft humanity has ever launched, a probe called New Horizons. This was the craft that flew past Pluto and sent home the first close images of that frozen world, then kept going, out past the planets, into the deep dark of the outer solar system. And out there, it held a rare advantage. Here near the sun, space is never truly dark. It is filled with a faint haze of sunlight scattered off countless tiny dust grains drifting through the inner solar system. a soft glow called the zodiacal light that pollutes every attempt to measure the real darkness of the sky. But New Horizons was far beyond all of it. Out where the sun was just a bright star and the dusty haze of the inner system was left behind. For the first time, a camera was sitting in genuine, profound darkness. To see why that mattered, you have to understand how delicate the measurement is. The leftover glow from all the unseen galaxies in the universe is extraordinarily faint, dimmer than the light of any single visible thing. To detect it, you must first account for and carefully remove every other source of light. The glow of nearby stars, the haze of dust, the scattered shine of our own galaxy, the faint light of everything in the foreground. Near the Earth, the dust haze of the inner solar system alone is brighter than the signal you are hunting for, and it drowns the whole thing out. Only from the deep outer reaches, far from that haze, could a camera hope to measure the true faint background of the cosmos. The team had a chance that comes, perhaps, once in a generation. An instrument sitting in the darkest place humanity had ever measured from. So they used it to do something simple but profound. They measured the total amount of light coming from the whole sky. Not from individual galaxies, but the combined background glow of every galaxy in the universe, seen and unseen, bright and faint, all blended into one dim wash of light across the dark. The logic was elegant. If there really were 2 trillion galaxies, all of them, even the invisible ones, would still be quietly giving off light, and it would all add up into a measurable glow. More galaxies, brighter glow, fewer galaxies, dimmer glow. So they measured the glow, subtracted everything they could account for, and looked carefully at what remained. And the answer surprised everyone. The leftover glow was small, far smaller than 2 trillion galaxies would produce. The measurement suggested that if you took all the galaxies our telescopes can directly see and simply doubled that number, you would have very nearly all of them, not 10 times more, just about twice as many as we can already see. That pointed straight back toward the older figure, a few 100 billion galaxies, not 2 trillion. So, which is it? A couple 100 billion or 2 trillion? This is where the most honest part of the story lives. As of right now, we do not know. The 2 trillion figure comes from modeling the faint galaxies we cannot see and asking how many must be there to explain what we observe. The few 100 billion figure comes from measuring the true brightness of the sky and finding less hidden light than 2 trillion galaxies would require. Both methods are clever. Both rest on assumptions, and the distance between them is an entire factor of 10. The gap between those two answers is, all by itself, larger than the whole universe was thought to be for most of the 20th century. If the higher number is right, then for every galaxy we have ever detected, there are 9 more hiding in the dark, too faint and too far for any instrument we possess. We are like someone standing at the edge of a sleeping city at night, able to count only the few nearest, brightest windows, and forced to guess at how many darkened homes stretch away into the gloom. The lights we can count are real, but the darkness between them may hold the overwhelming majority of everything that is out there. There is something to admire in scientists being willing to say, plainly, that they do not yet know. It would be easy to pick the more exciting number and declare it the answer. Instead, the honest position is to hold both, to mark the gap clearly, and to treat that gap not as a failure but as a frontier, the exact place where the next great discovery is waiting. The whole history of this question has been one long lesson in humility. Every time we were sure we had found the edge, the edge moved. Every time we thought the sky was empty, it turned out to be full. To sit with an open question this large, and to feel wonder rather than frustration, is one of the quietest pleasures that science has to offer. There is a telescope that was supposed to help settle questions like this. Instead, almost the moment it opened its golden eye, it began to break our picture of the early universe. For decades, the Hubble Space Telescope was our deepest eye on the cosmos, but it had a hard limit. The light of the most distant galaxies is stretched so far by the expanding universe that it slides out of visible colors entirely, into the infrared, the warm, invisible light just past red, where Hubble could not clearly follow. So a new instrument was built to chase exactly that ancient infrared light. The James Webb Space Telescope, launched at the very end of 2021 and parked far beyond the Moon, about 1 million miles from Earth, with a golden mirror larger than anything ever sent into space. Astronomers had clear expectations. The first galaxies, the models said, should be small, faint, dim, and rare, only just beginning to form in the first few 100 million years after the beginning. The new telescope was meant to find them and confirm the picture. Instead, it found galaxies that were brighter, larger, and more grown up than anyone thought possible so early. It found a galaxy we now see as it existed only about 290 million years after the beginning, when the cosmos was just 2% of its current age. Then it broke its own record, finding one we see a mere 280 million years after the beginning. 280 million years, in the life of a universe 13.8 billion years old, the blink of an eye. The cosmos had barely begun, and already galaxies were blazing with light. And these early galaxies were strange. They were too compact, too bright, too chemically mature for their age. They held heavier elements that should have taken far longer to form. It was as though the lights of the universe had switched on far earlier and far more fiercely than any theory allowed. The telescope also turned up a baffling new population, small, intensely red points scattered across the early universe, which astronomers have nicknamed the little red dots. Nobody is sure what they are. They might be densely packed early galaxies bursting with newborn stars, or the glow of rapidly feeding black holes in the infant cosmos, or something stranger still that we have not yet grasped. They were not predicted, and they do not fit. The astronomers who built the models were not crushed by all this. They were thrilled, because this is what discovery actually looks like. It looks like finding what you did not expect, something that breaks your assumptions and forces you to think harder. The instrument built to confirm our picture had instead opened a growing gap between theory and what the sky truly shows. The first galaxies came sooner, shone brighter, and grew faster than we believed was possible. And every new one we find adds to the count, and reminds us how incomplete that count has always been. The deeper we look, the more there turns out to be, and there is no sign anywhere that we have reached the bottom of it. New telescopes are already coming, some to survey the sky far more widely than this one can, others rising on the ground with mirrors tens of feet across, each one built to peel back another layer of the dark. There is one more way the most distant galaxies announce themselves, and it involves the monsters sleeping at their centers. At the heart of nearly every large galaxy, including our own, sits a supermassive black hole, holding the mass of millions or even billions of suns crushed into a region of warped space from which not even light escapes. Most of the time, these hearts lie quiet. But when one is actively feeding, when gas and stars spiral inward toward it, That doomed material is heated to ferocious temperatures and blazes with light just before it vanishes forever. The result is one of the brightest objects in all the universe, a quasar. A single feeding black hole can outshine all the hundreds of billions of stars in its entire galaxy combined, shining so fiercely that we can spot it across nearly the whole observable universe. From galaxies whose ordinary starlight would be far too faint to ever detect. So when astronomers find a quasar blazing in the early universe, they have found, by definition, a galaxy. One holding up a lantern across billions of light years to announce that it is there. And the most distant of these lanterns shine to us from a time when the cosmos was less than 1 billion years old, which only deepens a genuine puzzle, because a black hole should need a very long time to grow so massive, and yet there they already are, fully formed in the universe's infancy. How they grew so large so fast, we still cannot fully explain. The gap between the two answers will not stay open forever. This is the part that makes it a living question rather than a closed one. New telescopes are measuring the faint galaxies more deeply than ever before, refining the count of what was once thought invisible. New measurements of the background glow of the sky, made from ever darker and more distant vantage points, will sharpen the other answer. Slowly, carefully, the factor of 10 will narrow, and one day, perhaps within a lifetime, perhaps longer, the two methods may meet somewhere in the middle, and we will finally know how crowded the visible universe truly is. We are listening to a question still being answered, standing at the exact edge where new knowledge is being made. So why can we not simply settle this and count them once and for all? It helps to sit gently with the reasons, because they reveal how strange this question really is. The first reason is the deepest, and it has nothing to do with the strength of our telescopes. The universe is about 13.8 billion years old, so light has only had that long to travel since the beginning. And light, fast as it is, has a speed limit, about 186,000 miles every single second, and nothing outruns it. So there is a horizon out in space, set not by any wall, but by time itself. Light from beyond it has not had long enough to reach us yet. Everything inside that horizon we call the observable universe. Everything past it is, for now, invisible to us, and may stay that way forever. You might expect that a universe 13.8 billion years old would give an observable region 13.8 billion light-years across in radius. But it is far larger. While that ancient light was crawling toward us, space itself kept stretching, sweeping the distant galaxies ever farther out. When you account for all that stretching, the observable universe turns out to be about 93 billion light-years across. A sphere centered on us simply because we have to be somewhere. And here is where we happen to be. And inside this lives a quiet, strange truth. We can never see any distant galaxy as it is now. We only ever see its past, frozen in the light that has finally arrived. The galaxy reaching us tonight from 1 billion light-years away. We see as it was 1 billion years ago. Whether those most distant galaxies still exist as we see them, or have long since merged into something else, we have no way of knowing, and never will. We are always looking backward, never at the present, and the farther we look, the deeper into history we see. The second reason is that galaxies refuse to be simple. When you hear the word galaxy, you probably picture a grand glowing spiral like our own, or like Andromeda, with sweeping arms full of brilliant stars. And those exist. The Milky Way holds somewhere between 100 billion and 400 billion stars, Andromeda holds around 1 trillion, the greatest elliptical galaxies, lording over the hearts of giant clusters, can hold tens of trillions of stars, dwarfing our own galaxy completely. But these grand photogenic galaxies are the exception, not the rule. Most galaxies are dwarf galaxies, small, faint gatherings of perhaps a few million to a few billion stars, dim and easy to miss, and there are far, far more of them than there are giants. There are even sprawling galaxies, as wide as the Milky Way, that hold so few stars they are nearly transparent. Ghostly things you could almost see straight through. So you immediately run into an awkward question. What even counts as a galaxy? Astronomers usually describe one as a large gathering of stars and gas and dust, bound together by its own gravity and wrapped inside a halo of invisible dark matter. But out at the faint end, the line between a tiny dwarf galaxy and a mere loose cluster of stars becomes genuinely blurry. And since the smallest galaxies are also the most numerous, the total count depends heavily on exactly where you choose to draw that line. Count only the obvious giants, and you get one number. Count every faint little dwarf you can possibly justify, and the number balloons. Galaxies come in a handful of broad families, and astronomers have been sorting them by shape for a century, ever since Edwin Hubble himself first laid out the scheme. There are the spirals, like our own and like Andromeda, with a bright central bulge of older stars wrapped in a flat turning disk, where graceful arms sweep outward, lit by the blue glow of young stars and the soft pink of gas clouds where new stars are still being born. Many spirals, ours included, carry a straight bar of stars across the middle, with the arms trailing off its ends. Then there are the ellipticals, which look nothing like the spirals. Smooth, featureless balls of stars, ranging from nearly round to gently stretched, filled mostly with old reddish stars and little gas left to make new ones. The largest of them are true giants, grown vast over billions of years by swallowing smaller galaxies whole. Between these families sit the lens-shaped galaxies, which have a disk but no real arms, as though they were once spirals that used up their gas and quietly faded. And then there are the irregulars, galaxies with no clear shape at all, often small and chaotic and rich in gas, sometimes twisted into strange forms by the gravity of a passing neighbor. The grand spirals fill our textbooks and our imaginations, but across the universe as a whole, they are the rare and lucky few. The faintest galaxies of all are so dim that we have only found them recently, and only because they happen to sit right on our own doorstep, circling the Milky Way like quiet moths around a lamp. Some of these ultra-faint dwarfs contain only a few thousand stars, scattered so loosely through their halo of dark matter that they give off almost no light at all. If galaxies this faint are drifting unseen around our own galaxy, just barely within reach of our finest instruments, then the wider universe must be littered with countless others like them, far too dim ever to be seen across the gulfs between galaxies. And every one of them, if we choose to count it, nudges the great total a little further upward. The third reason is time itself, refusing to hold still while we count. The galaxies we see in the distant early universe were captured as they were billions of years ago, and many of them have since merged into larger galaxies. The count has been quietly falling across cosmic history as small galaxies combine into fewer big ones. And this is not finished, not even for us. Our great neighbor Andromeda is drifting toward us, and over billions of years to come, The two giant galaxies are expected to fall together and merge into a single larger one. Where there were two great spirals, there will be one, and the count of galaxies in our own corner of the universe will tick quietly downward. So when someone asks how many galaxies exist, you almost have to ask back. Exist when in the crowded early universe, in the thinned-out present, or averaged across all of time, which is what our images actually mix together. There is no single moment to point to. The sky we observe is a tapestry of every era stitched into one frame. And there is a fourth reason, closer to home and faintly ironic. Our own galaxy gets in the way. The Milky Way is a flat disk of stars and gas and dust, and we are sitting inside it. So when we try to look out at the wider universe, a broad band of the sky is simply blocked by the crowded, dusty plain of our own galaxy, which absorbs and scatters the light of everything behind it. Astronomers call this blocked strip the zone of avoidance, the part of the sky where surveys of distant galaxies have to give up, unable to see through our own clutter. And even where the view is clear, there is the constant trouble of confusion, since not every faint point in a deep image is a distant galaxy. Some are foreground stars in our own galaxy. Some blurs might be one galaxy, or two, so close together they merge into a single smudge. Telling them all apart is slow, careful, uncertain work, and every one of these difficulties stacks upon the others. It helps, too, to remember that galaxies were not always here. In the beginning, after the universe burst into being and cooled from its first searing heat, there were no galaxies and no stars at all. Only a near-uniform fog of hydrogen and helium spread almost perfectly smoothly through a darkening, expanding cosmos. Astronomers call this long stretch the cosmic dark ages, because there was no starlight anywhere. The universe was dark, formless, and cold, but it was not perfectly smooth. There were the faintest ripples in that early fog, regions ever so slightly denser than their surroundings, and we can actually see the imprint of those ripples today. When the cosmos was very young, it glowed, so hot that light could not travel freely through the dense haze of charged particles. As it expanded and cooled, that haze cleared and the light was set loose at last. And it is still arriving now, stretched by billions of years into a faint hiss of microwaves coming softly from every part of the sky. Astronomers call it the cosmic microwave background, and it is the oldest light we can ever see, a portrait of the universe long before any star was born. Across that ancient glow lie tiny patches very slightly warmer or cooler than the rest, and those patches are the seeds, the original ripples from which every galaxy would grow. Woven invisibly through all of it was dark matter, that mysterious substance we cannot see, but whose gravity quietly shapes everything. It gives off no light and barely touches ordinary matter except by its pull. Yet it outweighs all the ordinary matter in the universe several times over. In those slightly denser regions, dark matter began to gather under its own gravity, building an invisible scaffolding, collapsing halos that would become the cradles of all that came after. Ordinary gas, drawn down into these halos, pooled and compressed in their centers until it grew dense and hot enough that the very first stars finally ignited, ending the long darkness. As more gas and stars gathered, the first true galaxies assembled, small and chaotic at first, glowing clusters of newborn stars cupped inside their invisible halos. And then they began to do what they have done ever since. They pulled on one another. They collided. They merged. A small galaxy would fall into a larger one and be torn apart and swallowed, its stars adding to the growing whole. Over billions of years, small galaxies built into larger ones in a slow, relentless act of cosmic assembly, until every great spiral and giant elliptical we see today, our own Milky Way among them, became the end result of countless mergers, a single grand structure stitched together from many smaller ones that came before. So when we count galaxies, we are counting snapshots of this assembly frozen at every stage, from the first faint clumps to the great wheels of stars in the present day. And it is the earliest of these, the very first galaxies kindling in the dark, that we most desperately want to see, because they hold the secret of how the lights first came on. As the first stars and the first galaxies caught fire, their fierce light began to change the universe around them. The neutral fog that filled all of space was slowly broken apart by that flood of starlight. In a great turning point astronomers call the reionization of the cosmos. Bubbles of cleared, transparent space grew around the first galaxies, spreading and merging into one another, until at last the whole universe became clear, and starlight could travel freely across it. That was the true dawn of the universe we know. A cosmos of glowing galaxies with clean, dark space between them, through which we can now look back and see them. The earliest galaxies were the ones that lit that dawn, the faint and distant pioneers that ended the long darkness, and they are precisely the galaxies sitting right at the edge of what our newest telescopes can reach. There is a quiet beauty in that first dawn. For its entire infancy, the universe had been dark, a cooling fog with no light in it anywhere, and then, in scattered points across that darkness, the very first stars ignited, and for the first time in the history of everything there was starlight. Those first lights gathered into the first galaxies, and from that beginning everything we have spoken of tonight slowly unfolded. When our telescopes strain toward the most distant galaxies, they are reaching for that exact moment, the morning of the universe, the first lights coming on in the dark. To feel the true weight of all this, let us gently multiply it out. Our Milky Way is so large that light, moving at 186,000 miles a second, takes around 100,000 years just to cross from one side to the other. Inside it live between 100 billion and 400 billion stars, and around a great many of them, planets. Every star you have ever seen, every story humans have ever told about the night sky, fits inside this one galaxy, and this single galaxy, beyond all human experience and scale, is just one of the points we are trying to count. Now take even the cautious figure of a couple 100 billion galaxies, and multiply by the stars in each, and you reach a total number of stars in the observable universe, written as a 1, followed by something like 22, perhaps even 24, zeros. There is a comparison astronomers love here, and for once it is honest rather than merely dramatic. The number of stars in the observable universe is thought to be larger than the number of grains of sand on every beach and in every desert on the whole of planet Earth. Every grain, on every shore, in every dune, across the entire world. There are more stars than that, and around a great many of those stars circle worlds of rock and ice and gas, some with oceans and skies, and perhaps, on a tiny fraction of them, something we would recognize as alive. Think for a moment about everything held inside a single one of these galaxies, our own. Hundreds of billions of stars, some young and blue and furious, some old and red and patient, some swollen into giants, some shrunk down to glowing embers. Between them drift great clouds of gas and dust, dark nurseries light years across where new stars are quietly being born. There are dead stars too, the cinders and the collapsed cores, and at the very center, a sleeping giant black hole around which the whole vast wheel slowly turns. Our own sun is just one ordinary star among all of these, riding a quiet arm of the spiral, taking more than 200 million years to circle the galaxy a single time. And around the sun, a handful of small worlds, one of them yours. All of that, every bit of it, is contained within a single point of light in someone else's deep field image. Let your mind rest on just one of those distant galaxies for a moment. Any one of the faint smudges in a deep field image. It is not really a smudge. It is a turning wheel of perhaps 100 billion suns, and around a great many of them, worlds. Somewhere in that single point of ancient light, there may be oceans catching the glow of an alien sunrise, mountains and storms and quiet shores, all of it utterly unknown to us and forever beyond our reach. Its light showing us only how things stood there billions of years ago. Every faint dot in those images hides that same depth. A whole galaxy's worth of places, multiplied across the thousands of dots in the frame, and across the millions of frames it would take to tile the sky. The richness folded into each single point is part of why the true number resists us. We are not counting dots. We are counting worlds upon worlds, gathered into islands, scattered through an ocean with no charted far shore. It is almost impossible to feel these distances in the body, so let us try, just once, slowly. If you could somehow climb aboard a beam of light, the fastest thing there is, and ride it outward from Earth, you would cross to the moon in a little more than a second. You would reach the sun in about 8 minutes. You would pass the outer planets in hours, and leave the whole solar system behind in less than a day. And then you would fall into the long dark between the stars, where even at the speed of light it would take you years to reach the nearest one, and tens of thousands of years to cross our own galaxy from edge to edge, and only then, with the entire Milky Way behind you, would you begin the crossing to Andromeda, the nearest large galaxy, riding your beam of light for 2.5 million years before you finally arrived. That is one single step among hundreds of billions. The scale does not shrink the more you think about it. It only opens wider. And there is a strange peace in simply letting it. And there is something worth pausing on here, quietly, before sleep. The heavier elements that built the world around you, the iron in your blood, the calcium in your bones, the oxygen you are breathing in this very moment, none of it was made on Earth. It was forged inside stars, in the hearts of suns that lived and died long before our own sun was born, and was scattered across space when those stars ended, to be gathered up again into new stars, new worlds, and at last, into living things. Every galaxy we are counting tonight is a vast engine quietly building the ingredients of worlds and of life, one generation of stars at a time. So when you look up at that faint smudge in Andromeda, you are not only seeing a distant island of stars, you are seeing the same patient process that, in our own galaxy, long ago made the atoms that became you. It is worth letting one more strange fact settle over you, gently, as you grow drowsy. For all the staggering number of stars and galaxies, the universe is overwhelmingly made of empty space. If the sun were the size of a single grain of sand, the nearest star would be miles away, with nothing but darkness in between. Galaxies themselves, for all their hundreds of billions of stars, are mostly emptiness. The stars within them separated by distances so great that two galaxies can pass clean through one another and barely touch. And the spaces between the galaxies are emptier still. So the universe is at once unimaginably full and almost entirely empty, crowded with more stars than grains of sand on Earth, and yet so vast that all of them together barely tint the darkness. Both things are true at once. There is a deep calm in simply holding them side by side. That abundance leads to one of the most haunting tensions in all of science. The universe seems to overflow with the raw ingredients for life, with countless worlds across countless galaxies. And yet so far, the sky is silent. We have found no clear sign of anyone else. Maybe life is common, and we have simply not yet learned how to listen, or where. Maybe it begins easily but rarely grows complex. Or maybe the spark of a thinking mind is so rare that even across trillions of galaxies, it has happened only a handful of times, or perhaps only once. We do not know which is true, but the sheer scale we have uncovered changes how the silence feels. The more galaxies we find, the harder it becomes to believe we are alone, and yet the harder that silence becomes to explain. While the great telescopes stare deep at single specks of sky, a different kind of effort has been quietly redrawing our map of the cosmos. Instead of staring deeply at one spot, astronomers have launched sweeping surveys that chart huge swaths of the heavens, measuring the positions and distances of millions upon millions of galaxies at once. One early effort spent years photographing the sky and measuring distances to more than 1 million galaxies, building the first truly large map of our surroundings. And it was that map that first revealed the cosmic web in full. More recent projects have grown bolder still, one measuring the distances to tens of millions of galaxies using thousands of tiny robotic fibers that drink in the light of thousands of galaxies in a single exposure. And another, a dedicated space telescope, setting out to chart the shapes and places of well over 1 billion galaxies in order to study the dark energy pulling the universe apart. None of these surveys catch the very faintest, most distant galaxies the deep fields reveal, but they do something just as important. They show us the architecture into which all those galaxies are set. Because the galaxies we can count are not scattered at random, like sand flung across a floor. They are woven into one of the grandest structures in all of nature. Map the positions of millions of galaxies, and a pattern appears that nobody designed. Galaxies gather into clusters, and clusters are linked to one another by long, thin bridges of galaxies, filaments stretching across hundreds of millions of light years. Between the filaments lie immense empty voids, bubbles of near-nothingness where almost no galaxies exist at all, so barren that a civilization near the heart of one might look out and see almost only darkness in every direction, with its nearest neighbors impossibly far away. And even inside the crowded filaments, the space between galaxies is staggering and mostly empty, a thin, cold, near vacuum, with great gulfs of almost nothing separating one galaxy from the next. The universe, on its largest scales, is overwhelmingly empty, with all its galaxies and all their trillions of stars gathered into the thin, bright threads of a web wrapped around oceans of hollow dark. The whole arrangement looks uncannily like a web, or the branching cells of a brain, or the structure of foam. Astronomers call it the cosmic web, threads of galaxies woven around great hollow voids, shaped over billions of years by the patient pull of gravity and the invisible scaffolding of dark matter beneath it all. Spend a moment inside one of those great voids, in your imagination, before you drift off. Picture a single galaxy, sitting alone, near the center of one, a wheel of 100 billion stars adrift in an emptiness, hundreds of millions of light-years wide. Any astronomers on its worlds would look up into a night almost entirely dark, with the nearest other galaxies so faint and so far that they might never realize the universe was full of company at all. It is a reminder that crowding and emptiness are both matters of scale. The galaxies seem packed together in our photographs only because those images squeeze unthinkable gulfs of distance into a single small frame, stretched back out to their true size. The cosmos is mostly silence and space, with the galaxies gathered like dew along the thin threads of the web, and vast hollow dark in between. And the web itself was not designed, it grew. Remember those faint ripples in the early cosmos, the slightly denser patches printed across the oldest light? Gravity spent billions of years patiently working on them, pulling matter out of the emptier regions and into the denser ones, draining the voids and feeding the filaments, until the gentle unevenness of the infant universe had been sculpted into the immense glowing scaffolding we see today. The cosmic web is, in a sense, those first tiny ripples grown up, magnified across billions of years and billions of light years into the largest structure that has ever existed. We are living inside the slow, finished handiwork of gravity acting on the faintest imperfections of the beginning. Our own galaxy sits within this web. The Milky Way belongs to a small cluster called the Local Group, ruled by ourselves and Andromeda and trailed by dozens of smaller dwarf galaxies. And that group is itself being drawn through the web toward a deep gravitational valley. When researchers mapped the motions of all the galaxies in our wider neighborhood, following the directions in which they drift, they found we all belong to a single immense structure, a supercluster of superclusters, which they named Laniakea, a Hawaiian word meaning immeasurable heaven. Laniakea stretches across hundreds of millions of light-years and holds the mass of 100,000 galaxies, all of them, ourselves included, slowly streaming toward its heart. And Laniakea, enormous as it is just one cell in a structure that fills the entire observable universe. So when you count galaxies, you are not counting scattered points. You are counting the light strung along the threads of the largest structure that exists. We are not standing still in all of this, either. Our whole galaxy is moving, and not gently. The Milky Way is racing through space, pulled along with its neighbors toward distant concentrations of mass, drifting through the great currents of the cosmic web at hundreds of miles every second. For a long time, astronomers spoke of a mysterious region toward which everything in our part of the universe seemed to be flowing, drawn by the combined gravity of countless galaxies gathered there, a pull so large it earned a name that sounds almost mythic. And when researchers finally mapped those flows carefully, following the directions in which all the nearby galaxies drift, much of that pull turned out to be the gentle gravity of Laniakea itself, our home supercluster, quietly gathering us inward. Even now, as you lie still, you are being carried across the universe at a speed no machine on Earth could ever match, riding the slow tide of everything. But here is the final turn, the one that quietly changes everything. Every number we have spoken of tonight, the 200 billion, the 2 trillion, the 93 billion light-year sphere, refers only to the observable universe, only to the part we can see. And the observable universe is almost certainly not the whole universe. Its edge is not a wall. It is only the distance light has had time to travel. Beyond that horizon, space continues. We cannot see it, and may never be able to, but there is no reason to think it suddenly stops. So how large is the whole of it, honestly? We do not know. But we do have a clue. From measuring the overall shape of space itself, space could, in principle, curve back on itself, making the universe finite though without any edge, like the surface of an enormous sphere, which is finite yet has no boundary you could ever fall off. Or space could be flat, running on and on without ever curving back, in which case it could be infinite. And every measurement we can make says space looks flat as we can possibly detect, with no curvature we can find. A flat universe is consistent with one that simply goes on forever. The visible sphere, with its hundreds of billions or trillions of galaxies, may then be only a tiny sliver of the whole, with all the rest lying forever beyond our reach. Some of our best theories go further still and suggest the universe may be truly, genuinely infinite, stretching without end in every direction. Think about what that would mean for our question. If the universe is endless, and galaxies fill it the way they fill the part we can see, then the number of galaxies is not 200 billion and not 2 trillion. It is without limit. An endless ocean of galaxies, more of them no matter how far you travel, never thinning out into any final dark. In that case, the question, how many galaxies exist, has no number as its answer at all. We have learned to count the galaxies of an entire visible universe, and in doing so, we have come face to face with the very limit of what counting can ever tell us. And the number we can see is not even fixed. In the long run, it is shrinking. The expansion of the universe is not steady, it is accelerating, driven by something we barely understand and simply call dark energy. For most of the 20th century, astronomers assumed the expansion must be slowing, gently braked by the gravity of all the matter pulling inward. Then, near the end of the century, two teams measuring distant exploding stars found exactly the opposite. The expansion was not slowing, it was speeding up. Something was pushing the universe apart, overwhelming the inward pull of gravity, carrying the galaxies away from us at ever-increasing speed. We still do not know what this dark energy is. We only know it appears to make up the great majority of the energy of the universe, more than all the stars and galaxies and dark matter combined, and that it is steadily winning the cosmic tug-of-war. It is humbling to admit how little we understand the thing that is shaping the entire future of the cosmos. Dark energy has no agreed explanation. We do not know whether it is a property of empty space itself, a faint tension woven into the vacuum, or something stranger we have not yet imagined. We know it only by what it does, by the way the most distant galaxies are quietly accelerating away from us, as though space had a will of its own to grow. And whatever it is winning. All the matter of the universe, every galaxy and star, an unseen scrap of dark matter together, is slowly losing the long, patient contest against the gentle stretching of space. And here is the gentle, sobering consequence. The most distant galaxies are being carried away so quickly that their light is slowly losing the race to reach us. Their light is stretched thinner and thinner as space carries them off, and far into the future. More and more of them will slip beyond our horizon and vanish from view for good. Billions of years from now, an astronomer in our galaxy would look out and see far fewer galaxies than we can see tonight. Eventually, almost all of them will be gone from sight. The cosmic web faded over the horizon, leaving only our own galaxy and its nearest companions adrift in what looks like an empty void. Beings alive in that distant era, with no record of what we know now, might gaze up and conclude, exactly as our own ancestors did, that their galaxy is the whole of creation, and that beyond it lies only darkness. They would have no way to learn of the trillions of galaxies that once filled the sky. There is a closer, gentler example of all this change, one that touches our own small corner of the sky. Andromeda, that faint smudge you can find with your naked eye, is not drifting away from us like most galaxies. It is falling toward us, drawn in by gravity across the gulf between. And in a few billion years, the two great spirals will meet. They will not crash like solid things. The stars within them are so far apart that almost none will ever collide. Instead, the two galaxies will sweep through one another, pulling out long glowing streamers of stars, passing and settling and passing again, until over a vast stretch of time they merge into one larger galaxy. By then, our sun will be old and the Earth long changed, and any beings here to watch will see a slow, silent reshaping of the whole night sky. It is happening already, far too slowly for any human life to notice. And it is happening everywhere across the cosmos, galaxies falling together and becoming fewer and larger as the ages turn. And if you follow that thinning forward far enough, into a future almost too distant to name, the universe grows quieter still. The gas that makes new stars is not endless. Slowly, over spans of time that dwarf the present age of the cosmos many times over, the great bursts of star formation fade, the brightest stars burn out, and the galaxies settle toward a long, dim, red twilight. There is no need to fear it. It lies unimaginably far ahead, far beyond the lifetime of our own sun, far beyond almost anything we can meaningfully picture. But it is part of the same gentle story. The universe had a dawn, when the first galaxies lit the dark, and it will have a long, slow dusk, and we happen to be living in its bright and crowded morning, when there is still so much light to count. Which means something quietly extraordinary about the moment we are living in. We exist in a brief, privileged window, when the universe is still legible, when its history is still written across the sky for anyone patient enough to read it, when the galaxies are still close enough that their light can reach us. We are among the fortunate few in the long story of the cosmos who get to see it while it is still full of light. You might wonder why any of this should matter. Lying here in the dark, far from telescopes and observatories, and perhaps, in the most practical sense of the word, it does not. Knowing whether the universe holds 200 billion galaxies or 2 trillion will not change your morning. But there is another kind of mattering. To live for a little while on one small world and to understand, even roughly, the size of everything, is a strange and quiet gift. It sets the worries of any single day against a backdrop so vast that they soften without being dismissed. It is humbling and steadying at the same time. The very curiosity that makes a child ask how many stars there are is the same curiosity that built these great telescopes. And it lives in you too, every time you look up and wonder. There is an old thought, from an astronomer gazing at a photograph of the Earth taken from the edge of the solar system. A single pale dot lost in a sunbeam that held within it everyone who had ever lived. The galaxies stretch that same thought almost past bearing. Our entire world, every person, every life, every story across all of history, has unfolded on one small planet, around one ordinary star, in the faint outskirts of a single galaxy, among hundreds of billions, perhaps trillions, perhaps an endless ocean of them. And yet, far from making us feel small, there is something quietly magnificent in it. We are the part of all that immensity that somehow learned to look back at itself and count. The galaxies are silent. We are not. And all the while, even now, even as your eyes grow heavy, the light keeps arriving. From every direction, faint photons that left distant galaxies billions of years ago are falling silently onto the Earth, onto the roof above you, onto the dark side of the planet turned away from the sun, ancient light, older than the world itself, ending its long journey here, tonight, while you rest. We catch only the tiniest fraction of it with our telescopes. The rest simply arrives, unmeasured and unseen. A quiet rain of starlight from across the whole visible universe, falling softly on a sleeping world. So let us gather the journey up and name plainly what we have learned. The first thing is that our galaxy is not the universe. It is one island among an uncountable multitude, and a single pulsing star in Andromeda was enough to prove it. The second thing is that the darkness is not empty. Aim a telescope at the blackest scrap of sky, hold the gaze long enough, and thousands of galaxies bloom out of the nothing. The third thing is that what we can see is only a fraction of what is there, since as much as 90% of all galaxies may lie below the reach of every instrument we own. The fourth thing is that our two best methods of counting disagree by a factor of 10, somewhere between a couple hundred billion and 2 trillion, and that gap alone is larger than the whole universe was once believed to be. And the fifth thing is the deepest of all. Beyond our horizon, the universe continues, perhaps without any end, and the true total may be a quantity no number could ever hold. It is worth remembering, too, how this knowledge was won. No single person counted the galaxies. It took generations, thousands of patient people across centuries, grinding mirrors and building telescopes and designing detectors, working out the mathematics, staring at faint specks of light through long, cold nights, arguing and checking and gently correcting one another. It took a woman measuring pulsing stars on glass plates for almost no pay. It took a director willing to point a priceless telescope at apparent nothing for 10 days. It took a spacecraft sent billions of miles into the dark and then asked to measure the faint glow of the sky, and a golden mirror folded up and launched beyond the moon to catch light that began its journey before the Earth was born. The number we reach for is not the work of one mind. It is the slow, shared work of a curious species, handing its small discoveries from one generation to the next, each adding a little more light to the picture. And here is the thought I want to leave with you. In all of those galaxies, across that entire impossible range, whether there are 200 billion of them or 2 trillion or an endless infinity, there is, as far as we know, just one small world where a bit of matter slowly woke up, looked out across that ocean of galaxies, and began to count. That world is this one. That matter is us. We are a small species on a small planet, circling an ordinary star, in the quiet outskirts of one galaxy among hundreds of billions. And from that tiny perch, we have weighed the cosmos and read its history almost back to the beginning. So if someone ever asks you how many galaxies the universe contains, the most honest answer is not a tidy number. And it is not simply that we do not know. It is this. The universe holds more galaxies than we can presently count, and very likely more than we will ever be able to count. The galaxies do not know they are being counted. The cosmic web turns on, silent and indifferent. But we know, we, the counters, the ones who looked up and refused to look away. You have come a long way tonight. all the way from a single fuzzy smudge in Andromeda to the very edge of what can ever be counted. And now there is nothing left to do but rest. There is nothing to remember. Let the numbers drift away from you, gently, like leaves on slow water. It begins with someone looking up at a band of pale light and wondering what it was. It passes through a quiet woman measuring pulsing stars on glass plates, one at a time, and a man who found one of those stars in a distant spiral and learned, in a single season of nights, that our galaxy was not alone. It moves to a telescope aimed at apparent nothing that came back holding 3,000 galaxies. It rises to 2 trillion and falls back toward a few hundred billion and settles, in the end, into an honest and peaceful uncertainty. And it opens, at the last, onto a universe that may simply go on forever. Let that whole story loosen now and float away. You do not need to keep any of it. Let your shoulders grow heavy and soft, and let your breathing slow into a long, easy rhythm, like a gentle tide moving in and out along a dark and quiet shore. There is nothing to carry into tonight. The day is done. The counting is done. The galaxies will keep turning whether or not anyone watches them, and they will still be there in the morning, exactly as they are now. You are safe, and you are warm, and you are exactly where you need to be. There is nothing more for you to do tonight. The great questions can keep. They have waited billions of years already, and they will wait gently through the night while you sleep. Let your hands grow soft and still. Let the weight of the whole day sink down through you and away. You do not have to hold the universe up. It holds itself, turning quietly above you, vast and patient and unhurried, asking nothing of you at all but that you rest. The sky above your roof is full, even now, beyond the clouds, beyond the planets, beyond every star of our own Milky Way. There stretches an ocean of hundreds of billions of galaxies, each one blazing with light, each one a universe of worlds, all of it real, all of it out there at this very moment, while you lie here and rest beneath it. Let that faint gray smudge of Andromeda be the last small light in your mind, one quiet island of a trillion stars, drifting softly in the dark. Rest now, sleep deeply, and let the gentle dark hold you until morning.